Hello everyone, I am Dr. Karthik, Assistant Professor from Department of Biomedical Engineering, SNS College of Technology. We are discussing about knowledge distillation, which is an optimization technique in deep learning. We saw about the structure of the distillation. Basically, it is the knowledge transfer happening between a teacher and a student model. And also we saw about the distillation loss. Intuitively, we want to teach the student how a teacher thinks, which includes the certainty or uncertainty of its output. For example, the teacher final output probabilities are 0.53 and 0.47 for a binary classification problem. We want the student to be equally uncertain. Probability should be almost close to what teacher has got the probabilities. The difference between the teacher and student predictions is the distillation loss, like we saw in the previous video. Temperature scaling. What is temperature scaling? It's adjusting the temperature parameter in the softmax function of both teacher as well as student models to produce softer probability distributions. What is softer probability distributions? If the difference of the probability over time is not very high, it is balanced, that is softer probability distributions. The temperature parameter T scales the softmax function exponential Zi by T divided by sigma j exponential Zj by T. This can be represented in the form of bar graph. You can see in the slide. So first bar graph is softmax without temperature scaling, and next bar graph is softmax with temperature scaling with T is equal to 10. Without temperature scaling, we can see there is a high rise of probability at score 3, whereas for all the other scores the probability is very less. Whereas when you look at the bar graph second one, we can see there is not high difference between the probability at 3 and other scores. So this is soft probability distribution. Soft probability distribution. So model architecture compatibility. The effectiveness of a knowledge distillation depends on how well the student model can learn from the teacher, which is greatly influenced by their architectural compatibility. Just as a deep, complex teacher model excels in its tasks, the student model must have an architecture capable of absorbing the distilled knowledge without replicating the teacher's complexity. This might involve experimenting with the student's model's depth or adding or modifying layers to capture the teacher's insights better. The goal is to find the architecture for the student that is both efficient and capable of mimicking the teacher's performance as closely as possible. Transferring intermediate representations, also referred as feature-based knowledge distillation, instead of working with just the model outputs, align intermediate feature representations or attention maps between the teacher and the student models. This requires a compatible architecture but can greatly improve knowledge transfer as the student model learns. For example, use the same features that as teacher has learned. So this is a diagram of teacher and student model. So the common data is going into the teacher and the student, as we can see in this diagram, and there is a calculation of the distillation loss as well. You can see the logits at the end. So the common data is going to teacher and student. It is similar to teacher and student referring to a same textbook, so that they will learn, you know, whatever is there in that textbook, something like that. So you give same type of features to the teacher as well as the student, so that how the knowledge transfer between teacher and student will be effective, that we can analyze. So this is about the distillation technique, knowledge distillation technique for optimization in deep learning. Thank you.